Hello everybody, welcome back to another video. I'm hoping you guys are all having a fantastic day. So in today's video, as you can tell by the title, we will be talking about snow and snowstorms and winter storms. So I do think it is going to be pretty exciting, but or dreadful for some, depending on whether or not you like snow. But notice that I've changed the title. I'm now going to be talking about several storms. The models have done a fair share of changing for the past 24 hours. While yes, I do still think there will be a winter storm. That's kind of what I've been saying the past few days. A winter storm is possible around the 200-hour timeline. I still think that's very possible, but there's a lot of models that show additional storms after that. There's some models that show new storms kind of before that timeline, which again would be around a week out from today. So I'm going with the title now saying several large winter storms are possible, and each one of them may be bringing winter storms. And just to show you, and as an example, look what I've pulled up on this map. Now, this is just one weather ensemble, right? By no means is this a forecast, or this is a kind of a good average of what every single model is showing. But notice, look at this one. This one obviously shows several systems across the north. One affecting much of North Dakota and Minnesota and the Midwest. One across the south central, really southwestern kind of almost United States. And one across, well, Michigan, Kentucky, and into Ohio, Michigan. I already said Michigan twice there. So there's a lot of differences, but I think there's a very, very active pattern coming, and I'm really looking forward to talking about it in today's video. Before we do that, I do want to say quickly that if you guys do find this channel enjoyable, or if you like these type of videos, consider subscribing. Obviously, don't subscribe just because I told you so. See the video, watch it, and if you do enjoy it, consider doing that. Hitting the thumbs up button, the same rules apply, right? And if you have any comments or concerns, please leave them down below, and I will do my best to answer those. Okay, now without further ado, let's start talking about this. So first off, notice let's go to a model that is singular, not an ensemble like a lot of these, which an ensemble, as you can figure, is a bunch of models put together. Or almost, what is this, 50. I'll show you those in just a minute, but I want to first look at the GFS, and I will let it run, and I'll just show you what it will kind of show. So here's a timeline, by the way, the 4th, the 5th, and the different times during the day. Just pay attention to the map, choose your location, and see what happened, and see what happened. So notice, right around that 200-hour, really this is before the 200-hour, the GFS shows this bulge of precip. It doesn't really show a storm out of this. It's barely a storm, let alone a winter storm. It doesn't even have any snow. Some models, again, this is just one model, some models develop a winter storm out of this. So again, that's already one. And this model doesn't agree with that. But I'm just saying that some do, so, whether or not those are accurate or not, it's hard to tell, which is, again, why I'm saying several. So some models create a winter storm already out of that, kind of across southern Canada, so it's interesting to see what will result. You can see the GFS almost does that. It just takes a bit while for it to develop. And as we push it forward, it does develop this very large system, which yesterday almost all the models were showing, the three main ones, and today they still do, except they've taken on some different characteristics. Notice that the GFS takes it more from the south, develops some snow into Missouri and Iowa, but it's more of a rainmaker. I mean, it's a giant system, just not necessarily a winter storm. I mean, there's not much winter precip with this, but it's a big one. And for November, yes, there could have been, there could be more snow with this, but again, the GFS hasn't been, it kind of stopped being as consistent as it was. There was 2 days of consistency, and now it's a bit all over the place. But again, there's quite a few models that still show a snowstorm from that system. Now, we're not done. The GFS continues showing a very active pattern. Look, it redevelops the system across the Northeast, develops snow across southern Canada, and continues showing an active pattern. So that's just one model. Again, that's a GFS. Let's take a look at its 12Z model run. So this is the one that came out just a few hours before the one I just showed you. There's several that come out in a given day. And let's see what this one does. So again, we're not really focused on a short range, which is kind of 150 hours and underneath, or less than 150 hours. We're focused on a medium to long range. So again, there's that little preset band where, if you recall, the GFS latest model run developed a system out of it. This one completely didn't. But look what it did at noon. It developed this system, and again, it kind of does that with the newest model run, but further towards the south. So this one has more snow because it has more cold air at its reach. And look, there's that southern branch of it, potentially very, very heavy snow across Illinois, obviously Wisconsin, Iowa. This is, again, more of a, it's probably not going to happen. Again, not a forecast. I'm just showing you, kind of trying to illustrate the difference on how much one model run can change. And notice that it does bring a lot more snow, and it still does develop into a massive beast of a system. So, and then you can see more activity, more precipitation, more snow chances and whatnot. So that was the one from noon. Let's take a look at the one from the morning hours. So this is the one that came out today at 6 a.m. So again, there's quite a few on a given date. There's actually 4. And let me show you this one and see what the similarities and differences are. So again, we do see a lot of inflow of precipitation onto the west coast. Look what it develops right there. It's a pretty big system, right? And right there, look at that. This is what it did today in the morning. Different from just the first 2 that I showed you. And again, this is all given in one day, so you can see how much the models jump around. But they all show a system, just some less snowy, some more snowy. Now it's a bit less, but again, that's going to change 1,000 more times. And I said that yesterday, and again, that is true, because I don't think that's ever not been true with the weather models. And notice there's our system, dropped a lot of snow, redeveloped into another one, dropped a lot of ice and snow across the northeast. Again, this is what the one in the morning today showed, so it's not really new information, if you will. There's the Clipper, almost nor'easter type hybrid, and quite a bit of cold air. So you can see the GFS definitely keeps things active and exciting. And let me just take a look at all these precip amounts for all these 3 weather models, and let me just show you the precipitation where it favors storms. So obviously the northeast, the midwest, kind of seeing quite a bit of that. The west and northwest especially getting zoned in by that. The newest model run only takes us to 240 hours because it always lags on behind in terms of its total accumulated precipitation. A kind of graphic, and it did just come out a few hours ago, so again, that's not the most up to date. But look at 384 hours out. It is very, very, again, similar to the one kind of that we saw, similar areas seeing lots of precip again, but all it takes is a little tiny difference to show some remarkable changes, whether or not it will be more of a snowy system or a rainy system. The system seems likely, or just exactly what happens and where is the $1 million question. And now I do want to show you the Canadian model. So this is another model that I like to use. It comes out only twice a day, so we can't compare it as much as, really as much as I would like. But let's see what it does. It only takes us to 240 hours. So even if it does show an active pattern, it will kind of only show the beginning phase of that, which will be that first system. So let's see what it does. Pretty similar to what the GFS does up until this point. It's rather dry, nothing too extraordinary. It does develop a bit of snow across Canada. You could see that little bulge of precip right around that same time frame. Doesn't develop a really big storm out of it across our viewing area. Look at that precip right there, drags in a bit of that moisture, and you can see right there it stops at 240. So it does develop a storm. It's definitely later in time than yesterday. Yesterday, when I was showing you this model run, this is what it showed. Let's see, right there, boom. You see that little guy? Way across the north, was earlier in time, and now it kind of ignored that and is more focusing on this, which yesterday it was just in the making, and today it is now finally showing it because, well, 24 hours have passed. So that's an interesting scenario. You can see we have cold air. Could this develop a kind of a closed low and develop a very slow moving snowstorm across central United States, or would it not be cold enough and this would just kind of briefly be snow and mainly just rain? And yeah, I mean, you can see it definitely shows activity. It's still 240 hours out, which is why in today's video the title is just kind of like several big storms. And yes, if you look at the GFR, the Canadian, it's just one that it's showing, but you saw the GFS, it shows several chances, right? Right there's one that could develop into a bigger one if it develops a bit quicker. Here's another one that could develop snow if it's a bit further towards the north, which a morning model kind of showed from this GFS one. There's a nor'easter that if it gets a bit more cold air could develop into more of a snow system, which some models do. There's a Clipper, so there's a lot of activity, to say the least, and I do think that's why the title is appropriate. Let me take a look at the European model, ECMWF. Now, this is a very good model. It comes out, again, only twice a day, only goes out to 240 hours. So even if we do, again, have an active pattern from this model, we only get to see the beginning of it, that one storm. So let's take a run through this. Again, it shows a lot of the similarities, and I do want to say that, yes, this little guy right here, it's going to be very close to the shore across the northeast, and I'm not going to talk about him in today's video, but if it does, eventually, some models have been making landfall on this with the northeast, some haven't. It's been a back and forth, and again, you can see it's not even that far out, so they're disagreeing on a system as such, and as much as they're disagreeing, which is a lot, let alone a snowstorm that's much further out. But it's kind of fun about the weather, But But again, even if this does occur, it's not going to be a snowstorm. It's just going to be in way too much of a warm environment. So, I'm just going to be focusing on something else. If it does come to it, the threat, I'll be making a video about that. All right, let's move on, right? So around this same time frame, if you recall, the GFS and Canadian developed this little system. You can see the European develops a pretty big storm right off the bat. Snow across the Dakotas into southern Canada, and it develops into a beast. I mean, a blizzard, a large cold front. Now, if you recall, the Canadian GFS start developing their systems kind of on the southeast front of this trough, which many times does. That's when here the conditions of the jet stream is the most powerful in this kind of quadrant of the trough, which in the larger pictures like this, if you have any precip, this sometimes again tilts and kind of does that backward shape, really slowing things down and potentially developing a blizzard on the backside. I just chose this location because that's what I did, but it can occur anywhere and relative to the position of the low. If the low's right here, the snow's going to fall here, right? And let me show you this. So there's already the European things that will form. The GFS and Canadian don't really agree on that. But then look, the European does start forming. You see that? Look, there's our trough. There's this kind of to the south and east of that trough, we have that low pressure. And look what it does in the last few slides. It starts slowing down and getting more of a northern twist. If this were to go out, would this develop a lot of snow for Canada, the northeast, or really eastern Midwest, or would it just kind of slide off? It's tough to tell. Again, we can only go out to 240, but regardless, it already has this big system to watch for, and there are a lot of activity across the west, and of course, a potential new one. Also, peep the lake effect. I mean, that could be impressive, and this is on the eastern shores of Illinois and Wisconsin, but wherever this occurs, either on the western shores of Michigan or Pennsylvania or New York, lake effect this year seems to be a very good bet, heavy amounts of it at least, because the lakes are warm. They probably won't freeze over for a very, very good amount of time. While, yes, they may kind of, for large cities like Detroit or Chicago, early on in the season, they may act as kind of a heat bubble and make a lot of the snowfall as rain. But if, once it gets cold enough to where that's not an issue, the lakes are probably going to remain ice-free, even if it's a very cold winter, which, again, I don't think it will be particularly, bitter. It'll probably be more active and snowy rather than cold and dry. Then the lake effect will be heavy, frequent, with any cooler air mass that comes over, there could be a large lake effect event. So it's a plus and a minus, I guess, if you want the snow, if you don't want it. But a lot of businesses depend on that lake effect across Michigan and areas around the Great Lakes. So I think it's a pretty darn good year for that, and there's already been some lake effect. Nothing historic, but it's been there. All right, now let's move away from my tangent. I quickly want to just show you the snowfall accumulations the European shows from that big one, because it develops it in particular fashion. You can see it's mainly north of the United States, right? But I forecast for southern Canada, and you can see that across much of Ontario, that would be a big event. 12 to 18 inches in the hottest kind of, if you will, coldest and snowiest area, but the hot spot, right? That's what we call it. And across the northwest, obviously, it depends. It most likely doesn't depend on whether the pattern's active or not across the Midwest, because it looks pretty confident that there could be a large just inflow of precip, and whatever results of that will result of it. But it seems like here it's more confident to occur, that snowy and rainy pattern depending on elevation and temperatures. And certain mountain ranges are a bit more confident. You can see the Sierra Nevada with the last model run, or not the latest, but the one kind of prior to that showed a lot for the Sierra Nevada, and the newest one not that much. So it differs, and it will jump around depending on, again, what will happen. So that was just 3 models, and let me show you the 51 ensembles. This is a good it gives us a good idea, because 3 is just a bit too little. With 50, though, we could see, okay, what's the general thinking in the weather community? You can see some develop snow a lot, like a ton of it, across really southern Canada and extreme northern U.S. Nothing really that big anywhere south, but that is an active pattern, just again, a bit far to the north, but most models don't show that. Look at this one. Obviously shows most likely here would be two systems kind of across the plains. This is just 15-day snowfall outlook, so we don't really see when the snow will fall, but we can infer that, a formation like this would probably come from 2 systems. This one you can see is more across Wisconsin, Iowa. Again, many locations could get impacted by this. It's not just, the upper plains or, and the northeast. Many areas. It all depends on the tracks, so at this point, I would say anyone really north of kind of that, if you were to split the country in half, right across Missouri, anywhere north of those areas, you could expect a snowstorm. I'm not. I shouldn't say expect. Kind of expect the possibility of a snowstorm occurring. Obviously, this will. Not everyone will see snow, depending on where that snow occurs. But as of now, it's just too early to say. Look at this one. Keeps it dry. No big snowstorms, but obviously cold air because look how much lake effect falls. So those are pretty big amounts right there across the lakes. This one keeps it also a bit drier, more towards kind of a drier pattern. This one shows snow, just lighter amounts, but pretty widespread. And then this is kind of the string where there was a few models that didn't really show much. But look at this one. It definitely shows quite a bit of snow across Montana into portions of the South Dakota, Nebraska. This one you can see tries doing something. Doesn't really come to fruition. Definitely would be a big storm though because you could tell by the characteristic feature of how that would develop. Let's move on. P10 you can see develops a winter storm. This one probably develops or at least one right there, a second one right there across into Canada. You look at this one, that's probably a trio of storms at least. This one's also another trio. This one develops a system down here with some snowfall potential anywhere else. Decent amounts across the northwest, but southeastern Canada also seeing quite a bit from that. Look at this one. Definitely an interesting scenario. This one keeps it more across western Ontario. So does this one, but it does bring decent snow into the Minnesota and the Great Lakes. And you can see that again. Some, three right there were in a row that kept it across the plains. And some keep it dry, but more maybe towards the southwest or maybe towards the northeast. So we'll have to wait and see. But again, I do think that there could be a very active pattern. Look at that one. It shows the northeast. This one's more across the Great Lakes. This one's, again, more of a drier scenario, which they're becoming more and far and few in between these drier outliers. And there's another one that could occur. Here's one that just dumps snow across northern Manitoba, Saskatchewan, Alberta, and Ontario. Not so much, I guess, for the U.S., but look at the Great Lakes right there. Really, the UP seeing a lot. There's this scenario. There's this. There's that. There's this. There's this. You can see all the kind of the spread between all these models, and a lot of them, there's some consistency. In some areas, most likely southern Canada will see snow nonetheless. It's just a matter of fact of whether or not it develops. Look at this one. This one shows snow all the way down to northern Georgia and Alabama. So while it doesn't show a snowstorm across kind of the U.S., it shows a lot across Canada. This would mean a pattern that is extremely cold. I mean, that would require pretty darn chilly cold air. Probably a clipper that looks like a clipper that would come down and drop quite a bit of that snow. So, see, some of them are drier, but they keep it colder. So I guess if you want the colder but no snow, there's a few models that do that. But you can see a lot of them are snowy. And look at this, snowstorm and then maybe some sort of a snow event into Texas. I mean, that is a very, very cold blast of air that would have to be required. Honestly, probably the better thing if that didn't occur. And notice right there into Ontario, a beast develops, lake effect. You can see with each model that run, however, the northwest is pretty darn snowy. But yeah, we'll have to wait and see. There's a lot of disagreement. There's a lot of agreement, but the agreement is kind of, again, outdone by that disagreement. It's more of a, it's kind of a interesting showdown between all the models. Here's the Midwest that I could show you with the most recent GFS ensembles. It's kind of a different family, and you can see this is snowfall accumulation. And again, not really much up until really the week from today. A week out from today, and then boom, an explosion of snow accumulation. Again, each model kind of showing its own thing. Some across Wisconsin, some across Illinois, some keep it across Minnesota, some really just keep it across Canada, some stay dry, or at least for the 240-hour timeline. But again, that's the newest model runs, which is why they don't go out the full extent. But if I were to click at the one that came out a few hours before that, you could see by the time 384 hours are over, majority are showing a snowstorm of some kind. You can see some wait a bit longer. You can see that one's dry, and then boom, a system. So again, guys, I think that it's only a matter of time before we do see some sort of a snowstorm potential and some heavy snow. And that's why I think today's video has a pretty decent title. Look at this one right here in the middle. What it shows. Boom, boom, boom. I mean, that's at least like 3 systems right there. So yeah, stay safe, guys. Stay tuned, and I'll catch you all on the next episode. See ya. Bye.